Okay, Yufan, please start.
Okay, hi everyone. Today I will present the FSE paper this year, Understanding Neural Code Intelligence through Program Simplification. And this paper actually talk about how to explain the neural networks. First, we look at the others. There are three others. The first is a PhD in Boston, and his research interest is mainly on the software engineering and deep learning for program analysis. And the others are two assistant professor in SCMU and Houston, and they all research in software engineering. And this is today's index. The first, we will introduce the background. What is the explanation of deep neural network models? Why we need to explain deep neural networks? And the second, we will talk about today's paper's contribution. What is program simplification? And then we will talk about the methodology and the workflow of this paper. And then we will talk about experiment. And finally, we will give some analysis for the experiment. The first is a very short and a brief, easy background. The deep neural networks remain stubbornly opaque black box, even after years of research on interpreting their behavior. So we all know that the deep neural networks are somewhat like the black box. We don't know how it works. We only just input the data and output the results. And it's substantially more problematic in safety and security critical applications. So based on this background, we need to analyze the behavior of the neural networks and try to figure out some ways or some methods to explain the neural networks. And for today's paper's contribution, it proposes a very simple yet effectively methodology to better analyze the input reliance of neural models in software engineering applications. And the most important thing is that rather than you study the network itself, it just relies on the input reductions using delta debugging. And our today's most important thing is the delta debugging algorithm. And the main insight behind the input reduction is that by removing irrelevant parts to a prediction from the input programs, we may better understand the important features in the model inference. And I give you a short abstract of today's paper. He just given a prediction, didn't think about the correct or not. We show that models inputs can often be reduced tremendously, even by 9% or more, while returning the same prediction. Actually, this is a bit intuition because we may think that if you reduce the input, you will lose some useful information. But this paper shows that you can reduce very tremendously, even by 9% of the input, while remaining the same prediction.
Okay, so here the delta debugging is more like so the process of debugging is more like it's a way of analyzing and experimenting. So just keeps all the other elements stable and change a certain part of element or certain part of the input. We can observe the difference. So for example, when we discuss about the differential analysis, so it actually have the same idea of delta debugging. So here for my we have a few questions here. So can you raise an example of input here? So you're saying about input reliance of neural models. So what is because in software engineering application, there are numerous neural models and have take different kinds of inputs. So can you raise a few examples? So for example, the input is the data, the input is the code.
Yeah, for this paper, the input is code.
Mm.
I will give some examples in the following
Okay.
Yeah, in the
Yeah. So here, so maybe I'm raising questions too early, but it's better because anyway, this slide is raised several questions. So what is input and output of the model? The input is the code per se, and what is the output? What is the model output?
Yeah, actually, this is it's not study the network itself. It just give us an idea that we can reduce input. So it actually can work on different tasks. So for different tasks, it has different input and output. And the idea is just to reduce the input size. So
let me rephrase. So you mean that they have different kind of networks, and all those networks take the input as a code, and some of the model maybe for generating comments, and some of the model may responsible for classifying the code category. And you mean that for all of these tasks, I reduce the code tremendously, even by 90%, and their predictions remains the same.
yeah,
Am I right? Am I
yeah.
right? It sounds like, yeah, it does sound counterintuitive, but let's have a look.
Yeah, I also think this is counterintuitive.
By the way, so I have one more comment on these slides. It's not about content, it's about your presentation. So it will be better if you just list a few bullets instead of giving 4 paragraphs or 4 sentences here. So yeah, I understand all your information has conveyed, but it's better to have a more more concise way. Especially this is just for slides instead of essay or article.
Okay.
Okay.
Yeah, I try to use some sign and let the important words very clear to you. And if you want to understanding the whole contribution, I think you can read the whole. But if you want to get some important words, I just give you the delta.
Yeah. Usually when we are prepare the presentation, especially this presentation for research work, so we usually follow patterns or routines. For example, what is problem statement, and what is hypothesis, and what is existing contributions, and what is additional contribution. So basically, as long as we follow such patterns, the logic will be fairly clear. And of course, when we writing paper, definitely one of the ultimate goal is to make our written paper can be accepted. So in terms of paper writings, definitely usually after the introduction, the final part, the last paragraph usually saying what is contribution in this paper, to tell the reviewer that okay, this is my contributions. Please consider to accept this paper. But when you are working on the presentations, usually the routines are like what is problem statement, what is challenges, and what is existing work, and how the authors address the problems. And finally, it's presented the contributions.
Okay.
Please go on.
Okay. Here is an example for program simplification. The original is a code, so the input is a code, and then use today's paper's method. You can minimize to a very short code, and it also has the same prediction. For this task is the method name prediction. I will show in the later. And here I just give you an example. What is the program simplification? And the smallest possible version of this program is still syntactically valid and yet the same prediction of the very short minimized program. And here is the workflow of this paper. Your first input.
Sorry, maybe Yufan has mentioned this, but I recap this here. So the model task here is going to generate the method name and when given a piece of code, right? So this is task per se. And it means that after we change or simplify it from the 3-line code into the 1-line code, and the method name on create will always be generated, right?
Yeah, for this example, it is the method name prediction. But I just this example just want to say what is program simplification. Yeah, it
Yeah.
actually this paper has two tasks. One is method name prediction, another is variable name debugging. So yeah.
Variable name debug.
Sorry,
Yeah.
what is method name
Uh,
prediction?
yeah, I actually show it in later.
Yeah, method name is that, for example, when you have a piece of code, you want to have a better, you put this piece of code in a function, you need to have a function name, right? So if a good function name, like for example, uncreate or save
Okay.
or save data, so it have very clear semantics there. But if we randomly name the function like A, B, C, X, Y, Z, it will be a bad name. Yeah, so that's just a name generation, more like a name generation.
Yeah.
I also have another question here. So when you are doing this program simplification, from this example, do you mean you just change the name of some, for example, here the bundle becomes U and the save in instance states becomes VE, right?
Yeah.
I just reduce the
reduce
the
word, reduce the character level word.
Yeah, it means that if we want to generate it for the model, if you want to generate an onCreate, the bundle and a save instance state it doesn't that matter. And what really matters is the s.onCreate method. As long as such API happens inside the code, the model will predict the onCreate name for such a method body. Right? Yeah. Yeah, Yufan, do you feel that it is more like an attention? Do you feel it's more like attention? So if we remove some, so the input is actually a method, is a method body, right? There's a can be considered as a sequence of tokens. Some tokens really matter to generate such a method name, but some of them actually is quite trivial.
Yeah.
So basically, it's kind of similar to our differential analysis task. So if we remove some things, replace some things, as long as the model prediction still remain the same, we think it is have a good, it have trivial contributions or trivial attentions. Otherwise, it have significant attentions. So it's more. I think the idea can be applied for explanation.
Yes, I also think so. Yeah. So here is the workflow. We first input the code and then into a DD module. This module just reduce the program to a candidate simplified program. And then you check whether the code is passable or not. If it is passable, then you go to the model. This model is for a specific task. Maybe just like the task we have mentioned, the method name prediction. And then it want to check whether it's the same, remain the same prediction or not. If remain the same prediction, it will then goes to another, deeper simplified. And then until it has the different prediction, then it will get the minimal simplified program. So the process is very easy, and some important things on the DD modules. That means how to reduce the program, and it uses the delta debugging. And
what do you mean by code is still possible? From the model, and it feels to me that because it is the model itself is not a compiler, so how could a code cannot be possible?
Because after you reduce the code, this maybe the structure is not meet the grammar, the program grammar. So,
but from your example, the structures does your structure still conform to the grammar rules or?
Yeah.
Oh yeah. So despite I got it. So it is still there's some syntax checker or the compiler front end to check whether the simplified task is still still compilable or still conforms
well
to.
compiled. Yeah. So
Yeah.
actually, this paper
please.
didn't give the code of the code possible. So it only talks about the DD modules. So yeah.
So basically, I think the code parser can be a component of DD module, because as long as we make sure, so we can consider the process of minimizing the program is a process of code transformation. So consider from the syntactic point of view, a piece of code is actually a tree, right? A tree. So basically, the simplification is actually to cut some nodes on the tree or change some node name on the tree, right? So as long as we can make sure such an editing or simplification, the result or the consequence of the tree editing make it still a tree, then it's supposed to be possible.
Yeah.
It's possible. I think it's possible to integrate the code parser as a DD module. But anyway, so that's just a technical alternative. Let's keep going on.
Yeah, I think this is another way, but this paper uses a very simple algorithm. Here is the algorithm. It's very simple. Yeah. Maybe I can verify. Use example. First, we have like the whole algorithm. I name it as W, and you can, and then the code first separate it to half, and we name it as A and B. And then this algorithm just predict the section A is whether same with the original prediction W. Yeah, then he will check prediction the part of B. So and he will also check whether the W minus A and W minus B. So he will check these four parts, whether they have the same prediction of the whole. And if some of them have the same prediction, he will just split the A into another two parts, and then repeat this progress.
Yeah, I think the process kind of clear. So in terms of presentations, in your future presentation, can you try to prepare the slides in animation, right? So here, instead of writing those stuff, here you still present their algorithms, but it'll be perfect. It'll be much better if you could, for example, prepare example of code, and then for delta debugging, it actually divided the code into two halves, right? The first half is you can consider A, the second half will be, and when you present them with some animations, it will be much more understandable, especially the audience here includes several undergraduate students. I understand it is only 1 or 2 years for you away from undergraduate students, but usually prepare more vivid animations will be very helpful for the whole audience to understand and join the discussion.
Okay, so this is the progress before this code. And then if these four parts are all different from the prediction of the origin, it will just change the partitions. For example, now he will change the whole to 4 parts. We can name it as like A, B, C, D. Then he will compute the same like PA, PB, PC, PED, and PW minus A, PW minus B, PW minus C, and PW minus D, and then check whether they are the same prediction of the original one. And for example, if like that the PW minus A has the same prediction of the original prediction, it will split the W minus A to another 3 parts. Here is max n minus 1, 2. That means now our prediction is 4. Yeah, and then it will change to 3. So we'll have another A, B, C. So in this progress, it will have all the passions and get the final most simplified algorithm. Any question here?
But I think I'm not an outsider for their debuggings, but I can only get a big picture of what you mean. Based on my existing background, but based my own background of their debuggings. But maybe you can ask the other audience, maybe Xiaoling, Ruofan, Yufan, etc., or Dr. Xiao or Changshen, to see whether they fully grasp your drawing or drawing-based explanation.
Yeah, actually, I think the whole idea is understandable, but maybe the detailed progress may be a bit confused.
Because I also observed that you're asking a question about time complexity. So I think if the audience would like to answer your question like time complexity.
Yeah, maybe I can you can first check whether these 3 questions you can answer, then you can check your understanding. Anyone want to answer these 3 questions? Maybe the first question. Anyone? The first is if you check the algorithm progress, could you check could you find some weakness? Here I give some hints. Here is a naive example. If this is the program and we use this division, could you think whether it works very, explainable?
So when you have the question, it's better for make sure at least I can understand your point. So once we have the division 1-1, do you mean this is the original version and this is a simplified version?
Oh no, this is the original code. This is the original code, and this is the the prediction. The original prediction is just 1. Minus 1 is 1.
So here is that the prediction is that to predict this function or so let me repeat it. So here's the model, and right. So you input the code.
Yeah.
It's a definition of the division function, right? And what is output?
The output is 1. So the function is just the division. So if you use this what
does this 1 means?
I just because now we want to reduce the code. We want to reduce the code to remain the same.
Yeah, I'm not asking about the reduction, the program reduction. I'm asking what is the original task of the model. So you provide examples for the naive example, right? So this means the idea is very easy for us to understand. So Kevin models, we haven't touched about this simplification. We're just talking about what is the task of the model. The model
the model is the division function.
Oh,
the code, yeah. Yes, we are not talking about the neural networks. We are talking about the algorithm.
Okay, we're talking about
Yeah.
So let me clear. Sorry. So you still need your annotation here. Maybe we can. So here the function you can consider this is the model, right? This is model
M. Yeah. You can consider the model.
And the input is 1 and 1, right?
Yeah. The prediction will be also the 1. Now we want to reduce this function. Use this algorithm. So could you find out the weakness?
But here we cannot reduce this function. We need to reduce the input, right? So what we reduce is not the model. What we reduce is the model input, right?
Now we want to reduce the code because we now want to check the algorithm is explainable or not, or like check the effectiveness
No,
of
no, no, no. Let me keep saying. So here is the when we apply this technique, the input is a code, right? And the subject is a model, right? The model, and we want to observe the model prediction. That's output. So whatever it is, and there's output. So the point is that we want to change the input code as much as possible so that output remains the same. Okay. Now in your examples, you're saying this there's the native example, this definition division. So can you point out this is I, M, or O?
This is the M.
Okay,
and
this is M.
Is I, and this is O.
Okay, okay.
We are
So
not talking
okay,
about
okay. So sorry for interrupting. So since this code M is O, so the input cannot be division 1, 1. The input can only be 1 and 1, right?
No, because we are talking about the algorithm. The algorithms.
We are talking about we definitely we're talking about algorithms, but
Yeah.
the function per se is the M, right? So M, you say this function itself is M.
Because now we want to reduce the function and remain the same prediction. Okay. If we use this algorithm to reduce the code.
Okay, so let me confirm the definition division. So this pink rectangle is M or I. So M per se will not be reduced or simplified. Okay. So what we induce is the model input. But now you're saying that, let me repeat your logic. The native example definition, division, this piece of code, you see it's a model, right? So if it is a model, it cannot be reduced unless it is a model input, right? You think about it. You think about it.
Now we want to reduce the module. We don't reduce the input.
We reduce the model. How could we reduce the model? The model, usually the model is a neural network. How could we reduce the neural network?
So we don't talk about neural networks. We are not talking about the algorithm.
Yes, the algorithms. So okay, tell me. So what is the input of the algorithm?
Yeah, the input of algorithm is the code, is the the model. You can say that.
How could the code is the model input, right?
The code is the algorithm input.
Okay, so does the model is algorithm input?
You just
here the question is the model an algorithm input, yes or no?
Pardon, please.
Is model an algorithm input?
Yes, the code is the algorithm input.
I'm asking, is model an algorithm input?
What is the model?
The model usually, for example, we're talking about the neural network model, right?
No, we don't talk about neural networks here. We talk about the algorithm, and the algorithm input is the code here, the P. Okay.
And what is it?
Yeah, the model here is the M. M is the, you can
M is what? M is what?
Here the M is the division module.
Okay, the M is the division model, and M is what is P0, and what is P0 then?
Sorry.
So very clear. So the concept should be very clear. So given a piece of code, if it's a model, we discuss based on the model. If it is input, we discuss as input. But it's very confusion for me whether this code is input or model.
Yeah, actually, I want to reduce the code. If you because this.
Yes, okay. So can you go back to the previous slide? So let's talk about the rationale of the. So I think we are very clear about the rationale of the algorithm, right? Just the workflow. The workflow, the input is the program, right? So here the input is program, and here the model is NN model, right? This is a deep learning. This is a deep learning model, right? Here, so the model per se cannot be simplified or is unmodifiable, right? It's unmodifiable, amount is unmodifiable. And what we can do is change the input program, right?
Yeah.
And here, when you write a set of code, that's kind of the definition, division, etc. So this is this the input programs or the model?
Yes, there are. This is the input program, but it is also the module. Because I want just to check whether the algorithm whether it has some weakness or not. Maybe
I can understand their debugging is notorious inaccurate because usually they will sacrifice some of the stuff. But for your example, say I think the concept here is I think it's a bit entangled. So here, if you want to say, I still cannot grasp. So giving a piece of code, how can
it's a bit confusing. Yeah, I can just explain for you because now I want to I think example to show how the algorithm works or whether it has some weakness. So, but however, the neural networks is very hard to explain. So I just change this neural network to a division function here. Okay, so now you can just think that this is the neural network models, and then here is our code. Okay, so now this code is just the same as the division, and you input 1 and 1. Then the perspective output is 1. So based on the algorithm, it will just reduce to the same prediction as 1. So during the the algorithm, it will reduce the whole program. Like if you just reduce to the A, and it will also output the same 1. And if you reduce it to B, it will also input 1. And it will, if you reduce it to A minus B or something like these 3 characters, the prediction of the whole modules will also be 1. That means this reduced algorithm actually maybe have some problems on this naive example. Can you?
I got your point, but based on explanations, I feel that maybe I can rephrase it for you, but based on explanation, I find there are some concepts entangled here. So let me try to rephrase your points to see whether I fully grasp your point. So given a piece of code, right? This given piece of code, and suppose we have a model. This is supposed to be a neural network model, right? So here in your examples here, it's more like giving this piece of code and giving the input, and the output is supposed to be 1, right? So that's it. So anyway, so there's some model like here. And if we want to reduce the model here, based on your explanation, I still feel that this part is the input. This part is input. For example, we reduce A divided by B into A, right? So here the model will still output 1, right? Because giving 1 and 1, and if we replace A divided by B as A, it will still be 1, right? And if we replace it with B, it will still be 1. So by this means, you think that since we are editing the tree, once we're editing the tree, if we just observe its output, maybe its semantics have been changed significantly. It is not what we want. Is that your point?
Yeah. Yes.
So here, I think your point here is you still assume there is a model N. Based on explanation, there's still supposed to be N. This N is basically a ground truth to make the prediction, right?
Yeah.
So this piece of code is not N. It's not a model. It's actually the model input.
Yeah, I just think this is the same as module and the.
No, it's not the standard model. So here, based on the algorithm, the P0, your code per se is P0, and there's still an N here. Right, and here this is a 2 supposed to be some factor there isn't the matter. So maybe based on Yuchen's point, maybe I can briefly discuss idea. So data debugging is first proposed to localize the bug. So there's a very simple idea. For example, suppose we want to write an HTML parser, or we want to write a calculator. So the calculator is supposed to be 1 + 1 - 2 + 1, something like that, or using, okay, maybe we're using paragraph and times 2. Okay, so this is the input.
Yeah.
And we suppose we have a black box, supposed to be a parser, and this parser will return its value b, right? So here is our program, and we want to know. And now here is our observation is that given an expression like this, and when we feed these expressions into the program, and when we didn't get any result, and it simply crash. Okay, so this is the problem here. So we want to know what part of input makes the program crash. So a very straightforward idea is that we split the input into half. So the first half is 1 + 1 - 2, or another half is 2 + 1 times 2, etc. So suppose when we feed this half into the program, it doesn't crash, and then this half of the expression into the program, but it crash. It means that some operations inside the second half makes the program crash. So by this means we further split the second half into another two halves. For example, we split 2 + 1 and as one half, and split the multiply 2 as another half. As long as find one half, like the multiplications still makes the program crash, but the rest makes the program not crash. And we can confirm that the last half, maybe the multiplication operations make the program crash. So this is the basic idea of the data debugging. We have a ground truth of the program. The program always feed us, the title program always feed us with some ground truth and observation. And we want to minimize the input to see what partial of the program, what partial input will make the program finally crash. So that's the basic idea of the data debugging. So let me come back to Yufan's explanation here. So here the problem is per se that which part of the, so we suppose we have a very long input. Now here our input is not an expression, instead it's a piece of code. Maybe this is a piece of code here. So this is the input program, right? And here, and we have a title model. This model has been trained, it's a neural network model. So by right, when we feed this program into the model, this model will give us a prediction. For example, with whether this piece of code is buggy, or whether this piece of code should have a good name, etc. So here so the idea is that to apply data debugging, and based on Yufan's descriptions, it will split the program into half, and then to observe the model prediction result, right?
Yes.
Okay, so I think this is kind of clear, but I'm not sure whether data debugging is a very good idea. So usually, if I'm the one who conducts the research, I will propose some hierarchical data debugging. The hierarchical data debugging is that the input is actually a hierarchical tree. So because, and we once discussed this for several times, a piece of code, syntactically speaking, is a tree, is a tree, right? It's AST. So basically, we need to apply the data debugging with regard to their syntactic boundary. For example, given a piece of code, and here is the function, right? And function there's if condition here. If we want to make the edit, we want to change the code, it makes no sense for us to just remove if. If we want to remove if, we need to remove the whole if statement. In this case, we need to make the editing on the tree. So if I'm the one who conducts research, probably the naive data debugging will not be the choice. Maybe the hierarchical data debugging will be the choice. And also, but anyway, so the big picture here is very clear. So we keep modifying the input or simplify the input to see to find how the resultant simplification can still preserve the model prediction. Okay. Okay, I think that's enough discussions for these slides. And Yufan, keep going on.
Okay, so this example, I just want to say that although the prediction may be the same, but you know, the code may be just change the meanings. If you use this reduced algorithm, the whole code maybe change its original meaning.
I would like to make sure that when they are conducting their debugging, they do not consider any tree structure.
Yeah, they just use this algorithm. They don't consider the tree structure. But I don't think it needed to consider because because this model is a neural network. You know, the neural network should understand that the behind the if is no need to consider. And I think use this algorithm, you can also remove the if behind the if because it's a neural network. Yeah, you can't. Yeah. And the second question is time complexity. So for a program with length n, so anyone can guess what is the complexity of this algorithm.
This might be a good questions. Maybe you can point out an audience.
Maybe okay, maybe Xiangling.
I think I'm still somehow confused about.
Yeah, it's good. I think it's good for you to ask some questions because I think here, if I make some assumption that a lot of people know about their debuggings and also their condition, please raise your questions. Maybe it's better for us to clarify.
Let me think about it.
Maybe I can first. You use.
So it's better for you to have animation. For example,
For example, here maybe we can separate the algorithm to A and B. It's a half. You can separate to half, and then you will, if it is contained in the A, you will then separate to another half and C and D. So it will if you repeat this progress, you will continuously separate to half and half and half. So the algorithm on this part is log 2n. Yeah. So here we should focus on this. So what is the time complexity on this part? Could you check?
This part checks whether P0 and P minus delta I have the same prediction, right?
Yeah. So yeah, you can have a think about. I just gave you the example. You first separate to the 4 parts, and then you maybe because you minus 1 now you change it. This part is not important.
So it's n.
It's n. Because it's a regression.
It's a recursion. It's not a
recursion. Sorry.
It's a n square.
Yeah, it's a square because every time maybe you can say that n plus minus a number. Yeah, and that's a constant. Yeah, and you will continue to until it only have one part, and then it will be n square. So this part is n square. So from my the paper said it's the time complexity is n square, and this proof is my understanding. So maybe it's not correct. I just think this is because the paper just say the time complexity is n square. It didn't give the proof.
But at first you split P into n partitions, and here you need to check n times, right? This line. Because here you split into n parts, so here does this line be called n times, or just once?
This n is different from this n. This n is the partition, and this n is the length. Yeah.
I think why do you think they're different? I feel maybe I don't get confused here, but I feel this n is your n here, right? Because for one partition, it will we split one partition further?
Pardon, please.
So given an NA partition delta I, right? So will we will we still split inside a partition?
Split.
I guess
It's still right. It's still
recursion.
neat. Yeah, it's still neat, right? I see. So the point is that what is this factor 2? This factor 2 is constant. It means splitting.
Half. Yeah,
is
but
3.5.
yeah, this n is 2 if you use the 2. Yeah, actually, I read this algorithm several times and then finally get that this 2 is actually the n. I also confused originally because it sometimes use n, sometimes use 2, and sometimes use this. So yeah, from my understanding, this n is actually 2, and sometimes they will change it to like 2n, that is 4, like this example. And then if you this 4 it will change it to 3 in sometimes. Maybe I just show again about what I talked about before.
Another question is, here you check whether some delta I would satisfy this condition, but how many? I think here maybe we have a loop here to check from delta 1 to delta n. Right.
Yeah, but n is here the n is a constant, you know.
Oh, I see.
Yeah, here is like 2. Yeah, so
is this paper a camera ready version or still a preprint version?
So what's the meaning of?
So the camera ready version means that this paper has a fun because we're talking about FSE this year. Actually, it has not been held, but the accepting paper has been defined. So are you choosing the archive version or
The archive version?
Maybe there's still some mistake on the algorithms, but the idea is still that
but yeah, I just draft the example on my draft paper. Yeah, for you may think that firstly it is just because it's initiated by 2, so it will initiate by the A and the B. But I just said if you will check A, B, W minus A and W minus B, if these 4 are all different prediction, it will then in this.
So I have a question here. What does this P? What does the length of P and N? What does this length of P means? Because N is actually the number of partitions, right? And what is this this mode P means?
Mode P means the length of the
program.
Code. Yeah,
the length of code.
Yeah.
And why compare the number of partitions with the length of code?
Because if like the code have 5 tokens, if partitioned to the 6, you can't partition to the 6.
I see.
Yeah. So
and what is return value in this algorithm?
Yeah, P that's
okay,
because
P.
the recursion, it's a recursion.
Oh, I see.
Yeah. So yeah, if the if you first the first step you separate to half and A and B. If it is this 4 is not correct, it will change it to separate to the 4. To have separate to 4 parts. And if the 4 parts there are some some prediction that maybe like PW minus A have the same prediction of the original one.
And
it
yeah,
will
there's a
go
P0.
to separate to 3 because it is n minus 1. It will 4 minus 1, will separate to 3. So it is a process that the n will become bigger like 2n. And if it had got the prediction, it will minus 1 to a smaller partition. Could you get the idea?
So I have a question here. Is this P0 or P?
This is P.
P.
Yeah.
So in this case, you're saying that suppose we want to suppose the factor is 2.
Yeah.
The first time we will have half and a half, right?
Yeah.
And when we're looking to this half, and we still splitting this half, and will this part be considered? Suppose I'm using the dashed here.
You name it like this is a W and this is A and B. And
Yeah.
you separate B to the like C and D.
Yeah, so does A plus C will be considered?
No.
Yeah, it's a little bit weird. Okay, I think that's enough for the technical details because we have several.
Well, consider A plus C in the in the 4 parts,
Yeah, and I'm asking where in the algorithms they consider A plus C.
Because if you
I'm talking about where in the algorithm we begin to consider A plus C.
Because A plus C is larger than B. So if the B contains the the prediction, it will only contain the B. If A and B didn't have the same prediction, it will separate to 4 parts, and then A plus B plus C will consider. Could you get the meaning?
So I'm asking where is the algorithm? So I understand your point that if A and B don't have cannot preserve the prediction, we will further split A and B, right? So where is the algorithm point on this? Your student algorithm. I'm talking about algorithm 1.
So you mean what is the code? What is the detailed code in the?
Yeah.
I just give you example. Here is here
right. So here, if I understand this is a recursion, but I cannot see. So you can see. Let me clear all of these.
Okay.
So here, suppose we have, and if we the initial factor is 2, right? So based on your explanation, this n is supposed to be 2.
Yeah.
All right.
Yeah.
And this if this n is supposed to 2, we will first start with only half and half, right?
Yeah.
And if we work on each half as a recursion function.
Yeah.
And we were only looking to, for example, this is supposed let's say A1 and A2, and it will go into A11 and A12, right? A11 and A12.
Yeah.
And further is going to 111 and 112 subtracts. So it's just a pure division, and it will not come back to see a big picture.
Yeah, but here is LCF. Here you consider a bigger picture. Yeah, for example, if here
I understand. So it's only existing in its parent. So for now, it has been P instead of P0. It means that if we go into these layers and want to find 1 does not work into 1, we're looking at 1, 2, right? So because if it's this P, it means this P here is a half, right? Because for the recursion, when we have a recursion, it will actually pass the P here.
Yeah, yes.
And the delta I is actually a P. So when we go into this algorithms, I only go into the half, right?
Yeah.
Maybe I still have a doubt that maybe this thing is constant.
Because this half is the smallest one. You don't need to think about the other parts because.
So how about it? So let me example. Suppose A11 cannot preserve the prediction, and then we look into A12, right? And this is A12.
Yeah.
And it will only look into A12 instead of A12 plus A2. Will not look at this part.
No, because A1 can have A1 is the shortest. Because A12 plus A2 is larger than A1, you know.
Okay.
Yeah. So they.
Got it. Okay. So maybe there's enough discussion on these slides. Maybe I can summarize a bit here. So the idea is that we have a specific way. So basically using the ground truth or the feedback provided by the model, as long as one prediction can preserve the prediction, it will actually go with this prediction and to further participate with details. And here, maybe the final question, but we don't need to discuss discuss this point here, is that sometimes we need to replace the partition instead of to remove the partition. You get my point. So for example, suppose it's a division. If we remove, here's for example, we change D into F, right? So it actually will not, it still remains the same, which means the D and F does not, it means that D and F doesn't matter for the model
Yeah,
prediction.
it's a token level and correct level. It's also experiment on correct level.
The character level.
Yeah, character level.
Okay, let's keep going.
Okay.
There's enough discussion here.
And then he experiment on two tasks. The first task is method name prediction. We have just talked about. He used the two neural networks. The first is code to vector, and the second is code to sequence. We first look at the code to sequence. It is published on SLR 2019, and here is the model framework. Actually, we have talked about the sequence to sequence model before, so I think you can understand it very clearly. The first is the encoder here, and this is the fully connect, and then he will decode it to a sequence. So the sequence here is a method name. So it first input the whole code here and use attention mechanism to get output, use the decoder. And then we talk about what is code to vector. And code to vector actually just get a vector to predict. So it's the same that it has a, you can consider this as an encoder and use attention to get a vector, the final vector. And then it uses a softmax to predict. So this is a generative model and this is a prediction model. So these are the most, these are biggest difference between these two models. One is a prediction model, another is a generation model. And then he used these two models to on the experiment. And another task is variable misuse.
Can I ask a question? The previous one. What is the prediction here? I mean the code to vector. Code to vector, the prediction, the final prediction.
Yeah, it uses this vector to predict the final method name. It has a large dictionary of the the method name, a large dictionary, and you use the code vector to predict whether this is the method name.
Oh, so both of them are used to for
predict the name.
Yeah,
method name. Given a code.
Yeah.
Okay.
But the problem is for the code to vector, how could a method name to predefine? So just like if I'm writing a program and this name has to be selected from a category, right? So into the task design is very weird.
But he just used this,
And also, I think the code for sequence is okay, but maybe it's still going to derive a sequence of character.
Yeah. For the vector is just use a vocabulary of method name. I also feel a bit, weird.
So I think the prediction, I mean right hand one, I mean the prediction one is should be simple than the generative one, I think, because you have the vocabulary.
Yes.
So think about it. If I'm the one who designed the case, we're definitely using a vocabulary, but definitely it's supposed to be a generative model, right? So, but the point is that when we generate the method name, it's not generated character by character. Instead, it's generated by token by token. For example, I'm saying that start group meeting. This is a function. So the first one is not going to predict S. We're going to predict start. The next one is predict group and meeting subsequently. So that is then start group meeting is supposed to be a method function. So that might be a more sensible design instead of to pick up an arbitrary method name from the vocabulary or generate a character by character.
Yeah, it has a a library of method name, and you just predict one of them.
It's better to have it has a library of the token name, and then we generate the method name by combining these tokens. So that would be more more sensible, make more sense.
But maybe the code vector is very old method. Yeah.
So you're talking about an experiment. Yeah. So then maybe you can quickly go through the presentation and give a few of my comments here.
Okay. And another task here is the variable misuse. The definition of this task is that given a tokenized sample, buggy or correct, the task is to predict 2 pointers into these tokens. The first is that one pointer to indicate the location of the token that contains the wrong variable or some default token if no bug exists. And another point indicates the location of any token that contains the correct variable. Yeah. So these are the definition of the variable misuse. And here is the original precision record, the original result of this model. And after use this, the data bugging reduce algorithm, you can see that the initial size may be like very high, and the final size use this reduced algorithm, it will be much smaller. So he just used this experiment, very simple actually, I think. And this is another view. The reduction percentage is very high, especially for like R model or transformer for the buggy testing, because the misused variable is just limited to some words, so it will have much higher reduction. And here is the observation. It's just the same I just talked about. And the final prediction score, just that this is the score of the probability of the neural network. And you can see that with the reduction, the score is remain mostly the same for the transformer and the RN, and that means that the reduction is quite effective, because during the reduction there's no loss of the prediction score. Even for the code to vector, it goes much higher. And here is the character level and the character level and the token-based level. And you can see that focus on the character level, it will much higher reduction, because the character is a much smaller tokens, so it will reduce more. And interestingly, this paper also have a section of limits. Yeah, he says some limits of this method, and you can also see some limits, because he said that this paper proposed extractive interpretation methods. So these methods present important regions of in the input, leaving it to the users to characterize the behavior of the model. And they limited on the models that use complex or non-syntactic features. So this method, they think that they use.
What do you mean by the leave it to user to characterize the behavior model behavior?
Yeah, because this is irrelevant with the model. This is just reduce the input. The use you know the user needed to understand the model. If the user don't understand the model, you can't figure out the behavior of the model. It's just the explain on the input. Yeah, I think the most of this paper are like the subject view, subject perspective. So here is the takeaway. The first is the delta debugging algorithm. The second is what is the program simplification. And the second is a bit related to my research. I think this is a bit like, reduced to atomic code. So that's all three takeaway.
So the first, I have several comments here. The first comment is about the paper. And I think the paper has already mentioned the limitation. So for example, even if we successfully simplify a program P into a P prime, and the model still have the same behaviors, maybe it is a problem in the model, right? Suppose we significantly change the programs into half, and the model still preserves prediction. Is really the problems that the input, do we really remove the irrelevant input? It is not necessary, right? So for example, given your input, suppose you just remove this return value, it is just simplified. And based on an example, the model still will give us a value of 1. That's really good stuff. Or maybe it is just a problem, the bug of model. The model is not so smart and accurate to recognize actually the semantics actually has already made a significant change, right? So I think we should start from a different angle. It's good that we can apply data debuggings, but whether we need to, it is also a question mark for me, whether the data debugging is really effective in this case. But the overall idea is that when we apply change on the program, the input program, we would make sure that such a change is supposed to be semantically can preserve the semantics. Then we align the semantic preserving, preserve the semantics with the preserve the prediction. And that is maybe the right way to go. For me, this paper really worries me is that there's no guarantee that the data debuggings can preserve the semantics. And even if the semantics is not preserved, it makes no sense for me to see the model prediction is preserved, right? So this is my first comment. So I think we need to, if in the future, Yufan, it's good for us to define several semantic preserving change instead of an arbitrary change. So this is one point. You can keep discussing this part, but you need to put more thought into this aspect. My second task is for your presentation. So I think there's a huge improvement in your last presentation, but it seems that the performance decreased for this presentation. May I ask how much time do you spend on the presentation?
I think I just last night and today's.
I hope that you can spend more time. I think I mentioned this several times for algorithm. So it's better. So you can see that when we discuss, we're not native speakers. For example, some Singaporean students like maybe Yufan and Xianghui, maybe their English is even better than I. But for us, we receive the Chinese educations. It's really good to make the rehearsal and make good preparations, because if we speak arbitrary English, it's not sound that professional. The second is that you cannot improve very much based on your presentation. it's good that I observe that I think you copy paste the paper, right? You copy paste the paper for your presentation. It's better it's good that you always have some notes on the slide and prepare what you're going to speak and what you're going to present. And that will be improved. I think for these slides, for these presentations, you convey the basic information, but if you can present even well, you can save a lot of our discussion time. And also, you can improve yourself further.
But I think a lot about the algorithm, and I also prepare the question. I think you may have.
I understand. So you understand the algorithm.
You know,
I'm talking about presentation skill. I'm talking about presentation skills. For example, if I'm the one who prepare the slides, these slides will be split into 10 slides, and each slide will actually showing the animation and slides by slide and showing the details, and that will save a lot of time for discussion.
Okay.
So you can think about it in your next presentation. You can think about it. Suppose you still have another algorithms, and actually, I'm going to say that delta debugging is one of the fundamental algorithms in the work of debugging, and it has been invented for more than. It actually, if I remember correctly, it is proposed in 1998 or 1999, and for now it has been proposed for 20 years. And for this FSC, this year, and the professors from Peking University win the best paper award simply by improve its efficiency, simply by improve the efficiency of delta debugging. And they win the best paper award. So this actually is a very interesting, very important, and a prominent approach. If you can prepare the slides and we can have more thorough discussions, it benefits for all of us. And maybe you will be the next best paper winners, maybe in 2 or 3 years. So you can have a try and spend some time on the presentation, and especially for algorithms, animation will also always be a very intuitive and time saving. Maybe when you prepare the slides, it takes some time, but really it saves a lot of time, not only for improving the time, but also for our discussion.
Yeah, because I don't know actually the delta debugging because I'm not the specialist. So for maybe like the last presentation, I know the attention. I know the theme, so I will prepare the important thing. But for today, maybe I don't know the debugging. So I just think, oh, okay, this is algorithm. I will present this algorithm.
Yeah, even for that. So I think this paper is self-contained. Even you don't understand delta debugging, it's done to prevent you for using animation for that. And also, I found that you have a habit of illustrating evidence by drawing something. It is good. It is good. But since you have preparation, basically you can just use animation for that. It will be easy. And actually, from my point of view, it's actually saving time. When you're making the animation, it can further your understanding of algorithm.
Okay.
Well, of course, I understand. It's quite understandable that I feel this algorithm writing have some problems. They may have some mistakes and typo in the pseudo algorithms, but it doesn't prevent us to fully grasp it. Okay, I think that's enough discussion for Yufan's presentation. Is there any questions for that?
By the way, I remember I read a paper in 1820. There is a paper also used the delta debugging, also about debugging input. I think it is the name of this paper. I also read that paper. I didn't find. I'm not that sure when the authors improved the delta debugging. Maybe it is also worth for you to to read that paper. Similarly, they also want to use the delta debugging to check which part caused the program to have crash. I remember, yeah.
I think for Yufan, for Yufan, I think it's good for the basics. Only the basics is good, and also later we can arrange some an award-winning paper presentation. So that paper, those papers win the best paper award to see how the award-winning paper looks like. Okay. Thanks, Yufan. Now let's come to Docas. The Docas will present us a basic idea of phishing web page detection. So this is a different topics than what Yufan have. Docas, will you please share the slide?
Yeah. Okay. 1 second. Okay. Yeah. So the paper I'm presenting is not very technical. So it's a survey of phishing attacks, including the types, vectors, and technical approaches. So the first section for this is introduction. Basic introduction to phishing. The objective of phishing is to obtain information from a target through deception. So as part of the paper's introduction, it explains why phishing attacks are, why phishing is such a is an important topic of research. And one of the reasons is that the number of phishing attacks has increased greatly. So from 2015 to 2016, it increased by 65%. And the average number of phishing attacks a month has also increased. And phishing is a high severity attack because, for example, in 2013 to 2015, the losses from phishing attacks was there's a great number of financial losses. So for the paper itself, the main objective is to summarize the phishing landscape. So how the authors categorized it is they categorize three the mediums of phishing, the vectors and channels that are used to conduct phishing through these three mediums, as well as the technical approaches for each of the vectors. The three mediums that the authors present are internet, short SMS, as well as voice. And for the vectors, SMS corresponds to the smishing vector, which is where phishing is conducted up through SMS, and then voice corresponds to phishing. And the internet medium has 6 other vectors, which include email, e-fax, which is an online fax system, instant messaging, including Facebook Messenger, Twitter, social networks, websites, as well as Wi-Fi. And for each of these vectors, some of these vectors may involve multiple technical approaches. For example, instant messaging can be involved in drive-by download as well as social engineering. And spear phishing is carried out through email and e-fax as well as other vectors. Okay. Next part.
Could you please introduce phishing a very high level? Yeah, because I don't have any background related to phishing. Would you mind talking more about this?
Okay. So the term phishing comes from the word phishing, as in phishing with an S. So the act of phishing it involves the attacker luring the victim using a bait, and then the attacker fishes for personal information from the victim. So that's why it's called phishing. And in the real world, this commonly happens when attackers want to gain personal information either from a huge number of victims.
Yeah, basically the phishing attack is to steal the user's credentials. For example, using password or trigger the user doing something else. So in terms of the cybersecurity, phishing attack is a way to leverage social engineering, and the successful of the attacker relies on whether the attacker can gain the help of the victim or the users. Usually, so in this case, in terms of cybersecurity, the human is usually the weakest part of the system. Assuming that you get the username, the password, or the messenger name or the birthday information to the attacker, then the system cannot defend it. So overall, the idea is that in the picture, the idea is that they have several ways through several methodologies, through several ways, through several mediums to achieve such a goal. For example, someone can send an email saying that I'm actually your boss. Please come to my room. Please give you can you borrow me some money? Or someone will just faking faking a web page like Facebook or PayPal and trigger you to input some username and password. And also someone will give you a phone call to saying that you are involved in some distributions or the money laundry crime, and please give them a phone call, etc. All these are faking news and a faking appearance, and the goal is to taking your credentials.
Is
Okay.
there any official definition of phishing? Because I think it's hard to define what is phishing.
I think there are several definitions. Please, Docas, please go. Please say.
Yeah. So one definition that was presented in this paper is that phishing is a scalable act of deception, which uses impersonation to obtain information from a target. So the idea is like Dr. Lin Yun said, phishing involves deceiving a potential victim and pretending to be someone else or something else, so that the victim will give the credentials to the attacker. Then the other component of that is that this act tends to be scalable. So it's not just a one-on-one, but the attacker will target many victims at the same time.
Okay, thank you.
Sorry, does that answer the question?
Okay, please go on.
Okay. So these are the areas that this okay, from a high level perspective, this paper does a survey of all the existing research on phishing phishing attacks, as well as a little bit of anti-phishing efforts, and then it summarizes it and categorizes it into these approaches. So the objective of doing this study is to identify existing vectors in the communication medium that are being exploited. So for example, to be able to see from the internet is a medium. So one objective is to see for the internet, what are some of the risk vectors which can be used for that phishers can exploit to gain credentials from victims. Then after identifying these vectors, it is then possible to develop countermeasures to prevent these vectors from being exploited further. So for example, with cross-site scripting attacks, once we know how cross-site scripting attacks happen, it's possible to develop ways to prevent them from happening. Then the second objective for this paper is to identify new vulnerable vectors, and so that preventive measures can be put in place. The paper also presents two possible applications of this research, of this survey rather. So the first application is for policymakers to know what areas can they make policies in, and what are some of the areas of the cybersecurity landscape that need to be regulated. For example, the World Wide Web Consortium, which is a body that makes policies for the internet. It can introduce web standards like the Web of Trust to address some of the concerns raised in the paper. And the second area of application for this paper is just for readers from every walk of life. So like ordinary people to understand what the current phishing landscape is like, and to be able to take precautionary measures accordingly.
Okay.
Okay. So the next section of this paper is the literature review. Okay. So this section of the paper goes through it summarizes individual papers. So the first paper is by Mohammed et al. This paper categorizes three types of attacks. So the first one is a mimicking attack, where the phishers prompt the victims to reveal their personal information by sending an email that mimics an official email. So, for example, in the Singapore context, you might have a phisher who sends email pretending to be, for example, a government official and asking the user to send personal information to them. The second kind of attack is a forward attack. These both, the forward attack and the pop-up attack, are both man-in-the-middle attacks. So the forward attack is where the phisher intercepts the personal information through a proxy website, and then it forwards the information back and from the real website, so that the attacker is able to see the information that the user is sending to the real website. Then the pop-up attack is similar to the proxy, to a forward attack, except that the attacker will open a pop-up, a browser pop-up, and the user puts in their credentials into the pop-up, which gets sent in to the attacker. This paper by Mohammed et al. Also presents a life cycle of phishing websites. So one very common way that phishing happens is that attackers will set up a website which users will visit, and the users will put in their credentials into that website, and for the attacker to access afterwards. Oops, sorry, did my screen go blank?
Yeah, but I think I can see your mouse moving.
Okay, I think my monitor got disconnected for a bit. Is it back now?
For me, it's just to see the slides of literature review, and my mouse is moving, and that's all. And we are looking at the literature review slide. Okay, yeah, that's the correct one. Okay, so the life cycle of a phishing website is that there are 3 stages to it. So as an attacker, first that I will plan, I will identify the victim that I'm trying to steal credentials from, and what data I want to steal, whether it's their login information or their bank account or like their address, as well as identify a technique. Then the phisher will deploy the bait, which can be the website, which is often a phishing website, and then the victim will submit the credentials to the website. Then once the victim submits the credentials, then the phishing operation is considered successful. And as a phisher, I can use the credentials to pretend to be this user. So for example, to log into that website and make bank account transfers, or I can sell the credentials on the internet black market. And selling on the internet black market means that other hackers can use it for nefarious purposes. Okay, then the second piece of literature review, it surfaces for a different way of categorizing phishing attacks. This is specific to the banking sector. So the first one is a dragnet method, where a website or email or pop-up will contain logos, corporate names, and trademarks from a proper organization, from a legitimate organization. The second method is rod and reel, where phishers will first contact prospective victims, for example, through email, and then you target them using false information. For example, if a phisher might contact the victim and pretend to be IT support personnel, and then feed them false information to get them to submit their credentials. Then the lobster pot method is the same. It's another term for a spoofed website, where the phisher will set up a fake website that looks similar to a real website, for example, a fake Facebook login page. And then victims who visit this page and don't realize that it's a spoof website may enter their credentials there. And the last method is gillnet phishing, which uses malicious code in either an email or website to infect users' machines and steal their credentials from that. There'll be a few more examples the rest of the paper will go into a little bit more detail of how this can happen. So I'll skip it for now. Then next 3 papers are mostly they classify classical and emerging phishing vectors. And this paper by Sahu et al. It investigates machine learning techniques to identify to classify malicious websites, and as well as detect malicious URLs.
So this falls more into the anti-phishing category of research, but it's also related to the current research about phishing. And then the next paper, it investigates attack vectors for malicious web pages, as well as tools to detect malicious web pages. Then the next literature review involves phishing email classification and evaluation methods. So this is specific to the email vector of phishing, where an attacker will send an email to a user. And this paper evaluates and classifies the actual emails that attackers send. So it identifies the features involved in phishing email detection, which include the basic features, features to deal with the topic model, as well as dynamic Markov chain features. And the paper also introduces some protection approaches against phishing attacks. Another paper introduces different mechanisms. So phishing attacks there are social engineering factors involved, as well as different delivery mechanisms. For example, whether phishing messages are delivered through email or website, as well as phishing. It introduces a little bit about phishing attack vectors, which the current paper that I'm presenting on will expand on. Allman also categorizes defense mechanisms for phishing into 3 categories, which are the client side, server side, as well as at the enterprise level. Which enterprise level will be more of the human factors involved in phishing. For example, telling your employees not to click on suspicious links. Okay, so as a summary for the literature review, the existing research tends to focus a lot on anti-phishing efforts. So at the point of writing of this paper, there was not any detailed discussion of phishing techniques, which is necessary to be able to develop effective anti-phishing techniques. Are there any questions for the literature review section?
Yeah, so the first literature review is good. It provides us an overview. Maybe we can go on. So maybe we can focus more because your FYP topic is more towards a specific task. It's more like the faking web page. It's more looking to a faking page. Now maybe you can keep going, and I will have some comments here. And by the way, have you prepared a few questions for the audience?
I have 2 questions embedded somewhere in this section.
Sure.
Okay. So as mentioned earlier, this is the key contribution for this paper, which is the categorization of phishing mediums, vectors, and technical approaches. The mediums and vectors I have briefly went through before. It is an interesting note is that for websites tend to be a popular vector for phishers to deploy baits, meaning that it's quite common for a fisher to set up phishing websites. But internet users normally assume that phishing attacks are usually carried out through email. So users tend to have a lower guard against phishing websites than emails. Then there's also another piece of information in this introduction, which for instant messaging. Instant messaging contains the earliest recorded phishing attack on AOL users, where the phishers pose as an admin and then ask the victims to provide their credit card and login details. So this is a classic phishing attack. Right, so moving on, this paper introduces, I believe, 21 technical approaches that phishers may use. So the first one is through browser vulnerabilities. One example of a browser vulnerability is URL obfuscation. This vulnerability happened in Microsoft Internet Explorer in 2003. What happened is that an attacker can input hex 1 character into the URL. So that can be seen over here. And when this URL is displayed in the address bar of the browser, the address bar will only show http www.microsoft.com, and it will not show the rest of this. Page. So the user will think that they are accessing Microsoft.com, but in fact they are accessing Microsoft.com at phishing.com. this issue was eventually patched, but that's one example of a browser vulnerability. Then the next one is window.create pop-up. What this is also in Internet Explorer. And what this allows an attacker to do is to create a borderless pop-up window on top of all the windows, so that the attacker can mask the website URL or the HTTPS padlock. So, for example, if there was a pop-up window over my current browser, then the attacker would be able to display a different address over here, or the attacker can display a padlock icon in place of over here, even if the site does not use HTTPS. A third example is a cross-domain vulnerability using DHTML edit ActiveX control, which is also an Internet Explorer. So what happens is that if a victim views a malicious website, the malicious website can use this particular set of controls to gain access to the web control of another domain, and then the attacker can replace on another site. The attacker can then replace and load malicious contents to a trusted site.
So here the DHTML and active control. So here the survey. So I know about the first and second one, but I'm not that familiar with these ones. So in the paper, is there an example there, or just using the words? You're just using a text to describe such a vulnerability?
Yeah, the paper actually doesn't really go into detail about what this vulnerability does. So if I did a little bit of research, so what this vulnerability, so this vulnerability, it bypasses cross-domain checks. So if the attacker can convince a user to view a specific HTML document, then they can execute a script in the local machine zone. So the local machine zone will allow the attacker to it's a security zone. So if the attacker can execute a script in the local machine zone, then they can access content from other domains that are not the current domain.
Okay. Oh, great. Please go on.
Okay. So right, that's a cross-domain vulnerability. Then the next one is browser plugins. So I think this is a little bit more known nowadays. In 2014 to 2015, the number of vulnerabilities caused by plugins doubled. And a big part of this was Adobe Flash Player. So some of the current solutions to deal with this vulnerability is to, number one, constantly update and patch the browsers to deal with vulnerabilities as they arise. And the second solution is that some browsers will discontinue support for certain plugins. For example, Chrome no longer supports Flash natively. Okay. Another browser vulnerability is autofill. So this vulnerability involves user interaction with the site. So what happens is that phishers can design a form that has a number of fields. So maybe there's like 2 fields, a name and email. And so the victim will see this form and they might think that, okay, I'm only filling in my name and email, so that's okay, I don't mind giving it to the website. But actually on the page, there can be other form input fields that request for sensitive personal information, such as the password, email address, or even a credit card number. So if I click on the site and then I use the browser's autofill feature, all those hidden form fields will also get filled up by the autofill feature. And then when I click submit, the attacker will be able to receive all those hidden
by the way,
hidden data.
Do you know how the browser recognizes which page to be autofilled?
No.
Please.
I believe I'm not sure about which page, but autofill is usually done by input tags. So if the input is tagged as like the input name is email or the input name is password, then then the browser may recognize that as autofill.
Yeah, given my personal experience, Chrome usually do this trick, but I think the Chrome is super accurate. When we investigating Yufan, when we investigating the phishing web page, will the Chrome's autofill mechanisms working?
I'm not sure.
Okay, maybe we can investigate this as well. So here, I think the phishing web page is actually a faking web page, and I think there's several AI technique working. We inventing or developing several AI techniques revolving around it. But I think it's a time to go beyond phishing into more variety of malicious behaviors there. But I can start. But anyway, I can start with the phishing kits projects. Let's keep going on.
Okay. So the second category of attacks is called click checking or user interface redressing. Basically, what this does is that it changes the changes the interface that's displayed to users. So there are 3 areas or 2 areas of click checking. The first one is by compromising the target display. So, for example, what an attacker can do is that they can overlay a div container over the entire website. So that if I click anywhere if I seem to be clicking anywhere on the website, I'm actually clicking on the div container. And then when I click on the container, I might execute an action that I don't intend to execute. Another way is that instead of covering the entire website, an attacker might have a partial overlay. So for example, if it's a PayPal phishing website, they might cover, sorry, not necessarily a phishing website, but if it's PayPal, they might cover the recipient and the purchase details, but they leave the pay button uncovered. So that when the user clicks on the pay button, the user thinks that they are making a payment for the item to be sent to myself, but it's actually the underlying recipient is actually the attacker. Another option is that the attacker can have an invisible iframe that overlays the target element. So if I have, let's say, a login button here, and I think I'm clicking on the login button, the action that I'm doing is actually not logging in, but doing something else.
Sorry. So here, the overlay. So the overlay page is shown on a legitimate or the phishing web page. So here you're saying about overlaying. The overlaying. So, I think we're talking about the phishing web page, right? So if we're building a phishing web page, the phishing attackers will present the overlay, will present additional page on the presented page, right? So why bother to using this overlay? So maybe, sorry, I may not get this part. The covering PayPal receipt. So for example, so can you briefly summarize what's the point of this overlay page? Because the web page itself is just a phishing web page, and it's okay for the user to click whatever button. Whatever button the user clicked, the information is just sent to the attacker, right? And why bother to using this overlay technique?
Right. I didn't realize this point when I was reading the paper, but I suspect that this is actually done on a legitimate website. So the attacker somehow injects elements into the legitimate website.
Through the browsers or compromise the legitimate web page or website.
Yeah.
Okay.
Then the second area of a second possibility for click checking is that instead of compromising the display, I compromise where my pointer appears. So you can introduce the attacker can introduce a fake pointer at another location. So instead of while the user thinks they're clicking this button, they're actually clicking a different button over here. Another alternative is that the attacker can position an invisible iframe under the pointer, so that no matter where the user clicks on the screen, they will actually click on that iframe.
So the basic idea is that we need to compromise the website, right?
Yeah.
So if we want to do this, we need to compromise the legitimate website. Okay, keep going.
Yeah. Then the third area is temporal integrity. So what this does is that it changes the element on screen between the time that the user hovers on it and clicks, or if a user double clicks on it, it changes the element in the time between the 2 clicks. So similar to the others, it can also deceive a user into doing something that they don't intend to do.
Keep going on.
Okay. Right. The third area is in cloud computing. So the paper summarizes 6 attack surfaces for cloud computing. The context of cloud computing is that right now, as a user, I can hire services from, I can hire cloud services, which can be software as a service or like platforms or infrastructure. So there are 3 areas of interactions here. So as a user, I will invoke cloud services, but as a user, I can also manage the cloud service, which will then actually use the cloud. So for example, as a user, I might manage AWS services, and then AWS will use the actual infrastructure. So there were 5 examples here. So in the first example given was in Dropbox. So the high level idea is that the cloud computing is a new area, it's a relatively new and upcoming area of the internet. So this cloud computing itself brings in new vectors for potential vectors for attacks. So for example, in Dropbox, the attacker was able to gain access to the cloud provider's network as well as the user database. In this case, there was the user database, the passwords were hashed and sorted. So the impact was not as great. But if the user database, if the attacker was able to gain access to the user's credentials and passwords, then the attacker would be able to perform actions on behalf of the users and potentially use those credentials for
sorry. So here, where this information is leaked? So it means the Dropbox leaked information.
So
you mean the LinkedIn leaves information of the Dropbox account?
Yeah. So the employee used their LinkedIn password as their company password. So the password was leaked through LinkedIn, and then the attacker used it to gain access to the Dropbox network.
Okay. So it is considered as a cloud considered as an aspect of cloud computing.
Yep. Okay. Then in this case, it's classified as an attack surface E, which is that the user logs into the cloud provider system directly to access the user database. The second example is Amazon Elastic Cloud Computing in 2008. What happened was that an attacker could modify an eavesdrop message between the users, virtual servers and the users. So even though the message had a digital signature, which is supposed to prevent tampering with it, the attackers could modify that message. And then by modifying the message that users send to the cloud provider, the attacker can perform malicious commands in acting as the user.
So what's the difference between this EC2 and the other EC2 and the other server?
Sorry, what do you mean by the other server?
Yeah, for example, when there's communication between the client and server, right? So they using signatures or using some encrypted traffics to preserve their privacy, right? So here you mean that how this EC2 and what is the vulnerability of this EC2? So the point is that so for your signal bullet, is there an information loss of the client?
Okay, in this case, the clients
and how this information or how the credential is lost in the signal scenario?
That's a good question. I realized that the paper doesn't really explain that whether credentials were actually lost, or is the attacker just able to impersonate
Yeah, so
whether
it seems
just
that the
it's-
attacker is compromised the user's account, right?
yeah.
And create a botnet. And how could attacker do this? Okay, maybe you have a question. You say what type of attack service did this exploit?
Yeah, so the question was just like of these like of the 6 directions over here, which attack surface did this involve?
So attack service, because not every student here have an expert has the knowledge of the security. Maybe you can explain what is attack surface, and then you can point out some audience. Yeah.
So okay, the idea is that within cloud computing, there are different kinds of interactions, and then each of these interactions, the more interactions that there are, the more, in the sense of the more loopholes that an attacker can potentially exploit. So if my user is communicating with a service, the attacker can exploit the communication from my user to the service, or the attacker can like modify or intercept the communication between the service and the user. So each of these different areas of communication, it is a potential surface for an attack to occur.
Okay, so maybe you can recap the scenario. So come back to the question. We can come back to the question. So here, yeah. So you mentioned there are several types of the attack surface, right? So maybe you can list or enumerate a few types here.
Okay, sorry. The list of attack surfaces is over here.
Okay.
So the first one, okay, I'm actually not sure why these labels were taken from the paper. It says A is service to user, but the direction is like this way. So my gauge is that it is the user calls the service, and then the attack is in the service's response to the user. Okay.
So in brief, so the question is asking that for the signal scenarios, which directions or which aspect does attacker launch? Does attacker launch his or her attack, right?
Yeah.
Okay, maybe we can pick up a notice here.
Sorry, Yijie.
Can you go back to the question?
Yeah, so basically saying that when they are using Amazon EC2 service, an attacker can modify and eavesdrop the messages, and also can perform the malicious commands on behalf of the users. So giving this kind of attack, which location or which aspect on the previous graph do you think will be conducted or applied on such an attack?
Is it user to service?
Almost. It's actually the user to the cloud. I realized that I didn't make it very clear here, but the attacker performs commands on behalf of the user. These commands are to the actual the actual server that the user like rents from AWS.
Oh, okay.
Okay. Okay, keep it going on.
Okay. There are other two other examples. The first one for Google Docs is the issue was that there was no protection for embedded images. So even after the document, okay, there are a few different, for Google Docs, there were a few different vulnerabilities. So the first one is that even after the document has, even after an embedded image in the document has been deleted, the image can still be accessed. And the resource owner of the image is still embedded in the URL. So there's a privacy implication because if the document was previously shared with somebody, and they will still have access to the previous version even after it's deleted. Then okay, for a DocuSign, DocuSign was a case where the email addresses of DocuSign customers were stolen. Then the phishers were able to conduct a phishing attack on these customers of DocuSign by sending an email to them pretending to be from DocuSign, and also sending at the same time a malware-infected Word document. So what happened was that because of this cloud provider, because of this provider which stores all the data in the cloud database, when the attackers were able to compromise that cloud database and get the emails for all the users, then they were able to use this list of emails to conduct a follow-up phishing attack on all of the users, sending a document to these users to infect their computers with malware, and then that malware can further be used to carry out other attacks.
Thank you.
Okay.
Yeah, but here I still have questions, and here the phishing. Phishing actually is actually a phishing account, right? So basically, the more factual information the attacker have, the more its messages sounds reliable.
So I think this cloud computing point was more of it's something that enables attackers to carry out phishing attacks rather than like cloud computing being a phishing attack in itself. Yeah.
And also, have the paper talk about whether the phishing web page actually, the phishing attacker deploy their web pages on AWS or Google Cloud, etc.
No, not really. It doesn't really.
So they are talking about they got the information from the cloud computing based on their vulnerability, for example, getting information from LinkedIn, etc. Right?
Yep.
Okay. Keep going.
Okay. So another area for that contributes to phishing is when an attacker injects malicious code into data fields, or they make use of a custom URL to the website. So for a custom URL, what they can do is that it substitutes the URL so that when you load the login page, it loads information from this other phishing page. Then custom URL can also include scripts so that when if the legit website in this case is susceptible to cross-site scripting, what happens is that when I load this website, it will also load this script, and then this script will run, and it will run the phishing code. Another possibility for using a URL to conduct XSS is to load a code from an external web page instead of like embedding the entire code into the URL.
So maybe you can explain a little bit about what is cross-site script. So that's a very basic idea, but I think not every student or not every audience are familiar with this concept.
Okay.
So I think from the example is already quite clear. So maybe you can pick an audience to say based on your example and lesson to illustrate or give a definition of what is cross-site scripting.
Okay, Yufan.
Okay, so I don't fully get the cross-site part, but I guess it's like if you have a starting website A, right, and then it tries to redirect you to a legit website B, but this B has been injected with like these scripts, or perhaps the B is just a completely phished version of the legit website. Is that right?
Docas, maybe you can make a judgment.
I think it's not exactly that. So
okay, maybe we can pick up another student. Let us have a try. Let more people to have a try.
Okay. Xianghui.
Yeah, hello. I also just give it a try. I'm not too sure also, but based on my understanding is that it's like a code. It's like you inject the code into the HTML, something like here, and then after that, when it runs, the browser don't know whether to execute the code or not. So because it just implicitly trusts everything, so it just execute the code. and from there it's able to retrieve out the information. Yeah.
Yep, something like that. So usually for a website, the website should only be executing scripts that originate from the website itself. And this is, if you're familiar with web, it's called the same origin policy. So in cross-site scripting, what happens is that it bypasses that policy, so that if I'm on website A, I might load a script from website B, or a script that doesn't originate from website A, and then I execute the script even though it's not from the same domain or not from the same origin.
Yeah, so basically it is a trade-off between the convenience and the security. So for example, if I'm a web developer, I know that some JavaScript on the other website is fairly useful and convenient for me to use. But right, I don't bother to copy and paste the script. Instead, I can just write a web page and just loading such a script, for example, from Facebook or from PayPal, from Twitter, and then their own JavaScript can run on my site. But this causes some security issues, like because JavaScript can run on your browsers, user browsers. Suppose I'm loading some malicious, if the website allows me or the browser allows me to executing some scripts from the other website, it will incur some malicious or some insecure cases. For example, if some users are injected some JavaScripts inject some web scripts from the malicious web page, then it causes a problem. So usually, actually the XSS, that means it will actually invoking the JavaScripts from the other website instead of my own website. And basically, it is quite natural and convenient for the web developers, but it might be cause a lot of problems for the user or the client. Okay, Docas, please keep going on.
Okay. Another thing that attackers can do with cross-site scripting. So previously, what happens is that also one thing they can do is that they can execute code on the current website. Another option is that they can inject a script that redirects the user to a phishing website, but without the user knowing. So the user will still see the original legitimate website, and they still think they're on the legitimate website. There are two kinds of.
By the way, how to redirect it? I see how I missed it. It's from examples. We are visiting index.php, right?
Yeah.
And here it attach a JavaScript, right? And what's the effect if the user click the links or what?
Then it will change the. It changes the. Okay, it will redirect. If your user clicks on this link, then they will get redirected to the phishing website.
Okay. And how does the user not knowing the reader without user's knowledge? And why just not require? Why this without user's knowledge? When it's redirected, user will know that, right? Okay, so there are several ways, and there are several tricks for that, and maybe we can revisit this point. Let's keep going.
Okay. So going back to high level ideas, there are two kinds of XSS cross-site scripting. The first kind is reflected cross-site scripting, which is a non-persistent attack. For an example of this is in the URLs we saw previously. So the script is not stored anywhere on the server, but it will be loaded when the user visits when a victim uses that URL. The second kind is stored cross-site scripting or persistent. So this is when the script is actually stored in the database. So for example, if I'm an attacker and I'm allowed to make posts to a blog, or I'm allowed to comment on the blog, then I can insert my script into my comment, and then it gets stored into the database. And when anyone visits that blog post and sees the browser loads the comment, the browser might execute the script. If it's not properly executed, the browser will execute the script that's in the comment.
But for the second scenarios, why they still call it XSS? Because the script is loading from its own website, right? Because the script has already been injected into the database.
Yes. I'm not sure about that.
Okay, but anyway, so the big picture is that some unexpected or illegal JavaScripts has been shown on the web page. And here, these web pages are all legitimate web page with totally legitimate URL. But the scripts, the malicious scripts are just present here. Okay.
Okay. Right. Then the next one is, I don't really think this is considered cross-site scripting, but the authors lumped it under the same category because it's also used to circumvent the same origin policy. So in this attack, the user visits a malicious website while they are still signed into a target website. Then the malicious website loads content from the legitimate website using an iframe. So you can think of it as the malicious website is able to fetch content from the target website, but the malicious website, because it's in an iframe, the malicious website doesn't actually have access to this content. But wait, sorry, I realized that doesn't make sense with the rest of this. How the attack works is that how the attack works is that the malicious website will display private information from the legitimate website as a captcha, and then the user will complete. The user is able to complete the captcha and then submit the information to the attacker. The reason for this is because the malicious website is not able to send the information directly to the attacker. But I realized that I did not answer why.
How this capture plays a role? Sorry, I didn't get the point. So
okay.
Okay.
So the malicious website will somehow get data from the legitimate website. For example,
yes. So the user does not visit the target website. The user is not visiting the malicious website already, right?
Yeah.
Okay.
So the malicious website may get information such as okay, this is a crumb from Yahoo, which I believe is it stores the session. It's related to the user session, and then the malicious website, for some reason cannot send it to the official directly. So what it does is that instead of sending this information, it displays it to the user as a captcha by
I got it.
and disguises it. Yeah. So that the user will see this captcha, and the users used to filling in captcha, so they just fill in the information and submit it to the attacker. In this case, what this captcha is actually an anagram of the user's email. So by tricking the user into filling in the captcha, the attacker will be able to unscramble this and get access to the email. And there are also more advanced techniques besides, because this is still quite recognizable. So there's a two-step one where the first step it inputs part of the email, and then the second step is another part.
So this information, by the way, it's not really need for the user to input its username. It's victim, like the victim 113.gmail. There's no need for the user. Why does the user want to input it? So based on my understanding, those session ID is very important, right? Compared to the username, because when the malicious website is using iframe to invoke the legitimate website, all it's need is just a session ID. All right, or it still needs some username possible.
The username, this username was just an example in the chapter
paper.
before. Yeah, in the paper.
Okay. Okay, please go ahead. This interesting to know. Okay, keep going.
The next area of the next technique for phishing attacks is drive-by download. So what drive-by download means is that when I visit a website and then it downloads malware onto my computer. So this can also happen when you view a HTML email and then the script gets executed. It can also happen when you download a malware-infected email attachment or software. So some examples of malware are keystroke logging and screen capture. So if I download a malware that does keystroke logging on my computer, then the attacker who's this malware can capture when I enter my credentials into a website and then send these credentials to the attacker. And then the same thing will happen with screen capture. So this category is a little bit different from other phishing attacks because the other phishing attacks involve some level of social engineering when an attacker will kind of manipulates the user into doing certain actions that leak their credentials. But in this case, once the malware is on the computer, then the user actually doesn't know anything that's happening.
But even if the malware is downloaded, how does it be executed? The user have to click it, and then the program is just executed. Is it then executes, right?
I'm not sure about it. I'm not sure about the details of how.
Yeah, I think the drive-by download is a very important of malicious web page because it actually, if we run a browser, run Chrome or Firefox, the JavaScript cannot build the file, right? Cannot write something into your file system, but unless you are using the browser to download something. So here, the drive-by download is a very interesting topic, and we went investigating a little bit. And here it also quite related to EGS FYP because we know that there's FYP, there's phishing web pages will actually trigger a lot of interaction. For example, interacting with you to taking your username, then take your password, or it is possible for it to trigger the user to visit some other web page and then download something. So in this case, it's also a very interesting topic, but somehow I'm thinking about it, just you mentioned, when the malware is downloaded from such a web page and how could it be automatically executed, or maybe we can investigate the point later, and please go on.
Okay. Another example of malware is a web Trojan, which essentially a Trojan is a malicious program that's disguised as legitimate software. So then it can trick the user into installing or running that software. So if the web Trojan is being run, then when the user visits a legitimate website, it can open a pop-up that requests the user.
And by the way, the children is quite familiar with the definition of children. But what is the web children? The children is that an injection into the browsers or?
It's a term used in the paper. I don't know the exact difference between.
Yeah, the children basically is actually stealing the credentials on your own machine, right? The local machine. Although for a phishing web page, it's just taking your credentials actions, but for the children deployed on the desktop or server, definitely it's going to scan your information and send it back to its hosts. But what is the web children?
My best guess is that web children is it sits on the browser instead of or it impacts the browser rather than the rest of the server.
Yeah. So point is that compromise the Chrome. Maybe keep going.
Okay. Another kind of malware is a malware that effectively turns the victim's machine into a bot as part of a botnet. So if the victim downloads a bot malware and then installs it, the malware will give the fisher access to the victim's machine, so the fisher can command and control the victim's machine. The idea is that the fisher will create an army of bots to create a botnet, and then by infecting by creating as large a botnet as possible, then they
So
can
that
either
is
use.
basically the consequence of downloading such a malware, right?
Yeah.
Okay, keep going. But for here, I think our research, because it's really interesting when we look into what happens if the malware has been downloaded. But for our cybersecurity issues, we want to prevent the user to download. So when the drive-by download, at least we would like to investigate it. But basically, it's more relevant to EJ's topic and how the drive happens. So when a download happens, it's just download, right? So we're more interested into how the drive happens and how the user will be driven. And that process is kind of interesting, but maybe you can discuss these later. Okay, keep going on.
Okay. Yeah. So they also give some examples of what a botnet can be used for. This is just the general botnet life cycle. So it gets infected, then it listens for a command when the CNC server, which is like the attacker, triggers a command, then it will retrieve the payload, execute it, and then report the result. Then eventually the program will get erased can erase itself from the client. Some examples of what a botnet can be used for is to send phishing emails or potentially to act as a web server to host phishing websites or to distribute them. I can look into details of how this works. I have not yet. Then the botnet can also act as a redirector to a phishing website or as a proxy service. Other things that are related to a botnet is that the attacker can use a botnet, can maintain the botnet by using this thing called a fast flux attack. So if the attacker has a single domain name, let's say phishing.com, the attacker can have a list of IP addresses that are associated with this domain, so that even if some of the IP addresses get blocked, there are still other IP addresses that rotate in and out to keep the domain name working. Okay.
You can skip his point that it's not our current focus, but it's really interesting. Okay.
Okay. Yeah. Then another area of drive-by download is session hijacking. This one is also more of like what happens after they download it. Okay. Then next area is JavaScript obfuscation. This is going back to a phishing website. A phishing website can use JavaScript to obfuscate the code area of the browser window. So it's similar to what I mentioned earlier, that they can change the.
Oh, really?
address.
The JavaScript can change the prompt. It seems
the paper that referenced this was in 2007. So I don't know whether modern browsers can do it still.
From what I know of this kind of attack, it's not allowed on modern browsers anymore. But what they can do is that usually they have like an iframe to obscure the actual legitimate address bar. Then they just overlay something that looks like a address bar on top of it. That was the way they did it, I believe. But it's not allowed in modern browsers anymore.
Okay. Yeah. Thanks, Darren.
Then another area that JavaScript can be used is that we can execute the picture-in-picture attack. So what this is that it opens a fake browser window. So this thing looks like it opens a fake browser window. So this browser window will look like a legitimate website. And then the user thinks that this is just a pop-up from a normal website to key in their credentials, but it's actually part of the fake website. Advertising is phishing using online advertisements. So it's related to drive-by download in that installs malware onto the victim's machine. But the difference is that in this case, the user is the malware comes in through the malware infected advertisement on a legitimate website. So the reason why this happens is that right now it's very easy for anyone to apply for online advertisement, and so phishers make use of it to potentially create advertisements that will be displayed on legitimate websites. Okay. So
Yeah.
that's all. Nothing much in for that.
Okay.
Next category is man in the middle. Okay, the general idea of a man in the middle attack is that typically in typical communication, the user is communicating with a legitimate website, and when there's a man in the middle, then the attacker sits in between the user and the legitimate website and intercepts the communication that happens between them. So this kind of attack is quite difficult for users to attack. For users to detect, and it's not. HTTPS and SSL don't help to protect against this because the attacker can just open SSL communication between the attacker and the website, as well as between the attacker and the user.
Yeah, so is there any prevention? So unless we look into the URLs, because the phishers has exactly the same behaviors of the legitimate web page, right? So is there any solution to detect it? For example, I'm just talking about EGS solutions, we usually create a dummy account. For example, we have a dummy Facebook account. And usually if it's a phishing web page, if I input the dummy credentials into the phishing web page, it will never allow me to log in. In contrast, if we input the dummy Facebook account into the legitimate web page, and we can log in. So just based on such a differential behavior, there are different behaviors, I can know which is efficient, which is benign. However, if the phishing web page using such a proxy and an in-the-middle attack, it may present exactly the same behaviors of the legitimate web page. And does the paper discuss what's the way to defend it?
Not really.
Not really.
The paper goes into like how it goes into more details of how the man-in-the-middle attack is conducted.
Yeah, I think the only way I'm not sure whether it is the only way. The way is that just to identify whether it has the legitimate domain name or the URL. For example, if it prevents like a Facebook, whether it is really using the Facebook domain name, is that the only way to defend it? Or okay. No, I do not expect an answer here, but let's keep going on.
Okay. Yeah, so there's a few ways to do a proxy. So if it's a transparent, the transparent proxy is when the attacker sets up a server that basically serves content from a legitimate website, and then it takes whatever user information is passed to it, and then forwards it to the legitimate website, and just in this case it sends a quick response back. But effectively to the user, from the user's perspective, they can't see the proxy, so that's why it's called transparent. Then your obfuscation is what was mentioned earlier. So they might use the actual domain name is this. They might obfuscate it by swapping on domain and subdomain, or using a country code, or substituting certain characters. So in this case, the L is actually substituted by a capital I, or by using part of the legitimate URL as a subdomain. Then other options are choosing a browser proxy configuration. So this involves on the client side, on the victim side, it changes the proxy setting of the browser to forward all of the victim's communication to the attacker's domain. So to change the setting, to carry this out, the phisher first needs to install malware on the user's computer. Another option is a relay attack. So Operation Chiew use search engine optimization to put the malicious website or to display the malicious website in search results, and then the malicious website forwarded communication between the user and the shopping website until checkout. So once the user checks out, then they get redirected to the phishing page, which collects their credentials. Then, yeah.
And yes, is there some defense? Is there a defense for such a way? Because all the behavior looks the same. The only defense is just a domain name disguise, right? Just to detect the domain name disguise.
Yeah.
Okay, let's keep going. I'm thinking about it. Maybe we can imitate such attack by ourselves. I'm not sure whether EJ have the time. So maybe later in the FYP project we can set up build such a man in the middle attack proxy ourselves to see the behaviors. I think the ultimate way that if it's possible from the semantics or behavioral point of view, we can detect the difference. Maybe we can have some interesting find. Let's keep going.
Okay. Right. The last point, it makes use of the attacker reverse engineers how a legitimate website how the API request happens. Then the attacker will write a script to perform certain actions on users' behalf, such as transferring funds. So it makes it seem as if the action is performed by the user. Then by using this technique, the attacker can request to view the victim's account details and then steal personal information.
Okay, keep going.
Okay. Another way that man-in-the-middle attacks can happen is through DNS cache poisoning. So the big picture for this is that right now, if you view a website, you usually enter the website's domain name. Then the DNS will translate that domain name into our IP address. But it's actually possible for to submit false records to the DNS provider, so that instead of being that when the user goes to the domain name, instead of being directed to the legitimate website, they get directed to the phishing website.
And Yufan, we once discussed this point before, right? By the way, Docas, is there the paper mentioned such a DNS attack? Because in this case, phishing attacker has to be combined with some DNS poisoning, right?
Yeah.
And I think in order if the DNS is totally poisoned, so from the attacker point of view, the challenger does not lie to how to construct a phishing or how to fake a phishing web page, because the URL has already been corrupt. So the point is how to poison the DNS server. So have they point on how such a combination can be conducted?
Let's see.
Yeah, basically there's two ways in this case. So first is that we need to have a defense for the DNS poisoning, but usually the DNS server actually have a very high security level, because a lot of people now says what a DNS poisoning is, and actually it's not that easy to compromise. Another way we think about it is that what if DNS has already compromised, and what if it has already compromised, and what is the way to defend it?
The paper brings up, besides actually modifying the DNS server, the paper brings up two other possibilities for doing this. So one side is that modifying the host.
Can you send the paper of DNS cache poisoning combined with phishing? So because we think about this idea before, and these ideas can only be addressed by dynamic analysis. But let's talk about this. Will you please send the paper link to me?
Okay, I'll go and find the paper link for this.
Okay, thanks, Docas. Let's keep going.
And moving on, a man-in-the-middle attack can also occur by opening a pop-up with a fake login screen when the user is browsing a legitimate website. So for this to happen, the attacker actually needs the user to first visit a compromised website, and then that compromised website will monitor, it monitors what other websites the user is currently browsing. And then when it sees that the user is currently browsing, let's say a website that has to do with shopping, then that compromised website will open a pop-up with a fake login screen. And when the user,
but from your screenshot, is it a legitimate PayPal?
Oh yeah, the screenshot, this came from the paper, but the caption was actually that this is an example of a pop-up login screen, but not a
Okay.
phishing pop-up login screen.
Okay, I see.
Okay. So
Okay.
for this one, yeah, okay. This is the second and last question. So are these two attacks the same? So they both involve pop-ups. The first one is a picture in a picture. So you open okay, I shouldn't say too much, now I give the answer. But yeah, so this one opens a fake browser window within the current page. And then this one opens a pop-up window with a fake login screen.
Also, your point is that asking their difference, right?
Yeah.
Or whether that's the same. Maybe you can point an audience here.
Let's for a friend here.
Hello. I think they are not the same.
Yeah. What's the difference?
Hello, Rabin.
Yeah.
Maybe I'm
Okay, just
giving
go through.
some. Yeah, okay. So, from my understanding, from the first one, the window is drawn by JavaScript, right? So the JavaScript is drawn such a window size. And for the second scenarios, the window seems to be the real window given by guiding generated by the browser, right?
Yeah.
And but so I have the questions for Docas here is that if it is since it is now it's a pop-up window, it's more like a single sign-on strategy, right? So you input a paper, right? Given a single sign-on, we input the username and password of the PayPal, then we can log in based on the PayPal account. So here, my question is, this part, if this is a man-in-the-middle attack, will this still be a legitimate web page, right? Will it be considered secure? The browser will still consider it secure or not?
I believe that for this one it's actually a fake login. So it's not it's a fake domain.
Because this part is really obvious. If the attacker cannot make this into a secure or convince the browser that this web page is a secure web page, then it will have a insecure alarm by the browser itself, right?
Yeah.
Yeah, maybe we need to see more examples. That's really interesting for the pop-up web page. And because our Phishpedia projects is actually compare the appearance. For example, when we have a PayPal web page, we need to compare the appearance of such a web page with the real PayPal web page. If the appearance looks really the same, then we look into the URL domain. So I'm really interested that when the domain can be disguised, or in this case, when they pop up a domain or pop up web page, pop up a window with the URL, and whether the URL in the pop up window is still legitimate. If it looks legitimate, then it can bypass. Such attack can bypass our Phishpedia defense. Okay. Okay. Thanks, Docas. Let's keep going on.
Okay. Right. So the next area of attack vector is a very broad category. So it's just mobile phones. So there are a few ways that mobile phones can be used in phishing. So the first way is from a mobile sender to a mobile target. So this transfer control from mobile app to another mobile app. In the case of a mobile sender, the prerequisite is that the victim needs to have downloaded a malicious application on their handphone. So once they've downloaded it, then the mobile from the malicious application can ask the user to perform certain actions from the phishing application, such as sharing on social media. Then the screen will request the user to log in to the application that is shown, and then the user will end up submitting login credentials to the phisher through the phishing application. Then the second area is from a mobile sender to a web target. So the example is that as long as a mobile sender, it's still from a phishing application. So instead of showing the screen that requests the user to log in from the phishing application, the user is directed to a phishing website for them to submit their login credentials. Then the phisher can also hide the URL bar of the browser to avoid raising any suspicion from the user.
Here the question is that what's the difference between the mobile sender to web target and the website or the desktop sender to the web target? Is there any difference there?
Or from a desktop sender?
Yeah. So suppose there the phishing web page is it's just online. And what's the difference for us to do it from our mobile or from our desktop?
I think the difference that you're highlighting here is not so much is the difference between the mobile and the browser. So on the mobile, the phisher can hide the URL that's being accessed if they're accessing a web target.
Oh, really? So for the mobile, I think there's still a browser, right? There's still a browser there.
Yes, but the browser is loaded within the phishing application.
Maybe because of the real estate of the screenshot, maybe they have difference, but I think the difference might be minimal or not sure. Let's keep going.
Okay. Then from the other direction, it's just starting from a web browser. Then you example is if you follow a link on the website, that is linked to the application that you installed on the phone. So
sorry, I missed your point. So what's the difference between the mobile target and the web target?
Okay, in the mobile target, the phisher opens the login credentials through the phishing application. But in this case, then they redirect the user to the web browser.
And what about the web target?
So it's the redirecting from the mobile application to the mobile browser is a mobile sender to web target. Then redirecting from the mobile browser to another browser website, from a website to a website is a web sender to web target.
Web target is called a mobile browser.
So the web target and web sender are both websites. Then the mobile sender and mobile target are both like mobile applications.
Okay, let's keep going.
Okay. Then this is phishing kits. So phishing kits for errors context is they are tools that enables phishers to generate the phishing websites or emails or scripts without the phishers actually needing to know how to code. So these scripts can be bought from the cyber criminal marketplace, but most of the phishing kits have backdoors that would leak out personal information that they harvest back to the original developer. So the phishing kits are one step back from the phishing websites. So they don't directly collect personal information, but they help would-be attackers to deploy their attacks. So instead of just selling phishing kits, right now the cyber criminals are moving into a service-based business model. So on top of actually developing the phishing kits and selling them, there's also they also sell the service to deploy and distribute the phishing kits or to host a phishing website. And then the third level is more financial matters like money use and financial data providers.
So here you're saying that the malware service not only provide how to develop the phishing kits or provide the phishing kits or provide a template for you to modify phishing kits, but also provide service to deploy the kits, right? in this case. So what kind of service can they provide it? So it will show us some, if I'm an attacker, so will that show me the vulnerable or compromisable general page, or allows me to create a new domain or create a new web page in a short time.
So there's one example of it slightly later on. So that example was it's called, I think, the universal man in the middle phishing kit. So for that one, the person who is using the service can create a domain for hosting their phishing kit using
For how
online.
long? For how long?
I'm not sure.
Okay. Okay, let's keep going.
Okay. Search engine optimization is it's part of the phishing because it's used to deliver phishing web pages to potential victims. So this is search SEO product called Black Hat SEO that will inject keywords of popular trends. So that once the attacker sets up a phishing website, they use this to make the phishing website more widely known.
Oh, really? Is that really work? Because so based on our experience and observation, phishing kits do not want them to be searched. So if you can investigate the phishing kits we download together, you will find that one of the prominent features of the phishing kits is that they want to avoid crawler. So they will have a robot.txt to say that do not crawl me. Ask the Google crawlers to not indexing such a phishing web page. Here you're saying that the search engine optimization, they're trying to advertising this phishing web page, right? So the problem of the phishing web page to be advertised is that it will be soon be exposed to the public, and then it will be put into the blacklist in a short time.
Yeah.
Maybe keep going
Okay.
on. I just make my comments. Yeah.
Okay. Thank you. Right. Next area is session fixation. The context is that because we're using because right now the internet mostly runs on HTTP and HTTPS, so that the state of communication between the client server is not easy.
Sorry, Docas, your voice seems a little bit becomes vague to me. Will you please make your mic closer to your mouth?
Oh, okay. Sorry. Is it okay now?
Okay, it's okay. It sounds better.
Okay. So session fixation is when how a user says login on a browser is that the browser typically sends a session, creates a session ID for the user session, and then it stores that session either in the cookie or in a form field on the URL. So what session fixation involves is that the attacker steals this session ID, and then using the session ID, the attacker can pretend to be the victim in any of the phishers attacks, in any of the phishers interactions with the legitimate website. So one example that was given is that the phisher will target, the phisher sends an email containing a predefined session ID within the URL, asking the user to log in. Then the phisher will attempt to connect to the session in the website using the predefined session ID. So if the user did not access the URL and they didn't log in, then the phisher will receive an error. But after the user logins, then that session ID is valid, and then the phisher can hijack the session, access the website, and act as if they are the user.
Basically, actually, you're taking the session and you did. But session can expire even if they go to the sessions. They cannot access the username and password, right?
Not necessarily, but if they have access to the session, then the attacker can send a request to retrieve the email, probably to send a request to retrieve the username.
Okay, let's keep going on.
Okay, next part is social engineering. So this is mostly the first line of any phishing attack, where the attacker will try to divert the victim from making rational choices, and then cause them to make emotional choices. So an example is the phishing might contact the victim saying that your billing, that problems with your billing, and you need to like log in right now so that you can fix those problems. So yeah, that's just one example of social engineering, and it links to almost all of the vectors that were mentioned in the original chart.
Okay.
Okay, then I combine these next two ones because they're very similar. The main idea is that an attacker can squat on a domain that's similar to the legitimate domain, so as to trick the user into thinking that this fake website is a legitimate one. So one way they do it is by similar sounding domain names, and another way is by typo spotting. So like some examples are here. You might have a missing dot or like missing character, etc. Then the next area of phishing related to phishing is spear phishing and whaling. For spear phishing, this is a targeted attack against either a group or an organization. So attackers may pretend to be an organization that victims have, or a service that victims have used before, or they can pretend to be somebody that the victim knows. And so the idea is that they send an email pretending to be, let's say, the IT support personnel, and they ask the user to download this file onto their computer. Then that file contains malware that the attacker can then use to deploy, for example, an advanced persistent threat. This is an attack where the attacker sits on the victim's network and it doesn't do anything very much but just lies low and then conducts espionage. So it collects information over a long period of time. Then spear phishing can also, to conduct spear phishing in this way, the attacker needs to have some information about what services the victim has used. So they can do this via browser sniffing. So for example, checking whether the victim has recently accessed a particular URL or not. So, and whaling is the same as spear phishing, but it's usually for high-level executives. So if the phisher can gain access to a high-level executive's, for example, email account, then they can do a lot more damage because they can send instructions to employees. Okay. Our next area is SQL injection. SQL injection usually happens if the web developer doesn't code properly. So if, for example, if the web developer allows the user's username or password to be concatenated directly into the database query, then a malicious user might, let's say, have a username, might construct a username in a specific way that it modifies the query. So in this case, the second statement will select all users where one equals one. So basically it's true. It selects all users and ignores the password key. The defense against this is just for your web developers to code properly and to catch these at development time. Okay, tag mapping. This is a form of kidnapping of a tab in the browser. So what happens is that the user opens a phishing website, which is a normal website. Then the user might switch to another tab and continue doing other things. Then while the user is gone, the phishing website changes to a phishing login screen to spoof a legitimate website. So the fake website might also change the favicon as well as the header, so that when the user clicks back to this tab, the user thinks that they've already opened it, so they don't check the tab too closely, but the tab might change into something, for example, like the Gmail login screen. So if the user doesn't check the URL again, because they think they've already, they
by the way,
sorry,
Kansi. Sorry, Docas. So here, what's the point for changes to the phishing login screenshot, and then why we need to wait the user to switch the tab? Isn't the phisher or even the attacker want the user to see such a phishing login screenshot?
Yeah, so the basis of this, the reason for this attack is that the idea that the user tends to trust a tab that they have already opened more than a tab that they're opening for the first time. So if they're opening the tab for the first time, then they probably check like they probably check the URL and like whether it's secure or not.
I see.
Right.
So this is more like a social engineering trick, right?
Yeah. Yeah.
Okay, keep going on.
Okay. And okay, that's all the technical approaches that are introduced in the paper. The next section talks about the combination of approaches. This is actually like I think it's quite straightforward. So I was thinking through this quite fast. This is a summary of some of the different combinations of technical approaches. So for example, man in the middle can happen with the wireless with a wire phishing or evil twin, or social engineering search, and it is connected to many of these other techniques. Yeah, so clickjacking on mobile phone, it's basically the same thing, except that some web developers might feel that clickjacking is not an issue for mobile websites, so there's a lack of defense against it. Cloud computing, also not much new information, but the paper draws links between cloud computing and cross-site scripting, spear phishing, as well as SQL injection. Then drive-by download. It is an expansion of the earlier point where the victim first visits a website and then the malware functions in the web proxy to carry out the man-in-the-middle attack. For example, the downloaded malware might redirect web traffic to the phisher's DNS and then send to a phishing website.
Okay, let's keep going.
And social engineering, it's usually the first step in the phishing attack, so nothing much. And man in the middle and mobile phone is it explains how mobile phones can be used to carry out man in the middle attacks. So there are usually two ways of doing this. So one is scheme spotting, when someone listens for activities that happen, and then when the activity happens, then the phishing application will hijack it and redirects the user. The second one is listening to tasks. So the phishing application polls and waits until the user runs a specific application, and then the phishing application will launch itself and present a screen.
Okay.
Okay. Yep. This was a universal man-in-the-middle phishing kit that I mentioned earlier.
Okay.
Yeah.
Is there a link for that or?
Yeah, it's it's not a it's an explanation of how it works. So using the phishing kit, they create a fraudulent. This is really old though. It's in 2007. So it creates a fraudulent fake URL using an online interface. Then the URL will communicate with the actual website and basically show whatever the website is sending to the phishing website. The phishing website will show it to users. So the victim then.
So is this phishing kit available to the public? Yeah, I'm really interested.
I'll go and research and see whether I can find it anywhere.
Yeah, so maybe when anyway, we are crawling the phishing kits. Let's see whether we can find some man-in-the-middle phishing kits, or maybe later we can all together to build up such a proxy and to observe how the proxy can look like. And that's really interesting topic. Okay. Yeah. Docas, maybe we can quickly finalize the presentations because it's already close to 5:20.
Okay. Yeah. Yeah, I think the rest are not very relevant. So just the conclusion. The conclusion is that the internet is the most popular medium of phishing, but because the mobile phone market has been expanding, the other two mediums are still important. Then the conclusion for the generalizes the attacks into two main categories. So first one is vulnerability exploitation, which delivers malware. And the second one is like phishing websites, which trick victims to visit the website and give out their information. Some of the approaches will fall into both categories. So for the first one, vulnerability exploitation, the precautionary steps are just to make sure that software is patched, and during development, developers need to make sure that the websites are coded properly. The paper recommends some like policy level changes or things to enforce website guidelines. Then the other recommendations are from this survey. Note that non-social engineering phishing approaches do exist. So relying on user education is not enough, and we need systems to counter the technical approaches. Then phishing approaches that detect the websites upon actually visiting the website is not sufficient, because once you visit a website, then drive-by download attacks can happen. So you need it's more desirable to detect the phishing website through the link provided. This is from the user's perspective. Then another potential area of research is that JavaScript is commonly used in some of the technical approaches. So any anti-phishing method that can identify malicious behavior of JavaScript would be useful. And that's all.
Okay, thanks, Docas. I think it's a very detailed, very detailed presentations, and I think you understand the paper well. And I think they do have a few interesting points to discuss. The first is that about so from these surveys, from my point, and I have 3 points to investigate. Maybe we can keep discussing in our individual meetings. The first is that because we are looking to the phishing kit, we're looking to the phishing kit, the static code. Maybe we may also investigate the dynamic behavior of JavaScript or PHP code, but I have to have a very detailed. We haven't got very details about how the runtime behavior looks like. Maybe we can look into, for example, we can monitoring what important resources some JavaScript is visiting or PHP code is visiting. They may also infer some potential phishing or malicious behaviors. So that is for your FYP project. And for EJS project, so it reminds me that maybe because for our phishing intention or PhishPedia projects, we are looking to using totally static approach. But it is not clear, especially when the DNS poison is happening. Definitely, we need to leverage dynamic analysis, just what EJ is doing. So maybe we can try this way. The first is that what dynamic analysis happens and what's the influence impact on the low static approach. And the second is that the man-in-the-middle attack. So when the man-in-the-middle attack happens, it seems that the malicious website will have exactly the same behaviors as the legitimate web page, and how do we defend this? Maybe we can further discuss these issues in our individual meetings. And also, it is also interesting to look into the malware as a service. If you have time or if the time available, maybe you can also investigate. We can also investigate whether the market exists and how can we look into the market. I think the good stuff is that if the market have that, if there's a market and the phishing kits can be purchased on such a market, it allows us to have more enriched samples to summarize the phishing kit template. Okay, that's all. I think it's already take quite a long time for our group meetings, and I hope you can. Anyway, so some of the topics are quite relevant, and some of the topic is good to know. And I also hope that all of us can involve in more involved in the discussions. And we may call this a day. Thanks again for Docas and Yufan. Bye.